Welcome to lesson 9.5, the volume of pyramids and cones. It's going to be a super cool lesson, as always, so I know you're not surprised there. So let's just do a little talking about the volume of pyramids and cones. So let me hit you with a little something right now. I'm gonna hit you with it, not literally, it's figuratively. Here's the fact, okay? Let me explain something. The volume of a pyramid, all right, copy this down with me. The volume of a pyramid is actually 1/3, all right, the volume of a prism with the same base and height. So if you took a prism with the same base and height and you turned it into a pyramid, it would have 1/3 the volume. So what does that mean? Well, let's see. What is the volume of a prism, right? It's just the base times the height. So what do we think the volume of a pyramid would be? 1/3 of the base times the height. Now, if you're really interested in this and you're like, I don't believe Mr. Siegel, he's crazy. Here's what I challenge you to do. Go home, find a pyramid, and find a prism with the same base and height. Fill your pyramid with water and pour it into your prism. In this case, it's a cone and a cylinder. And you will see that you could only fill up 1/3 of the prism. Did I just blow your mind? I bet I did. Oop. Well, while we're on the topic, let's talk about cones. Did you also know that the volume of a cone is 1/3 the volume of a cylinder with the same base and height? So let's see, the volume of a cylinder, once again, it's just the base times the height. So what do you think the volume of a cone is? That's right, 1/3 the base times the height. Totally cool. So once again, the same experiment. Take a cone, pour it into a cylinder with the same base and height. Only 1/3 of it gets filled up. Did I just blow your mind again? I bet I did. So today's lesson should be pretty straightforward, right? It's the same exact thing we did last lesson, except now we're putting a little 1/3 in front of it. So let's get started. If I want to find the volume of a pyramid, how do I do it? Well, I just need to know two facts. The base, the area of the base, and the height. I think we can do that. So let's go back to what we've done before. First thing we're going to do is find our base and draw and label it. So look at this nice little base right here, okay? It looks like a nice little rectangle, something like that. It has a width of 3, height of, and a side of 4. Since it's a rectangle, to find the area of it, all right, the area is just the length times the width because it is a rectangle. All right. And so to find the area, we're just going to plug in our facts, 3 and 4. 3 times 4, and the area of the base is equal to 12. So let's just plug that right on in. Now the height, it's right here from the top to the bottom is 10. So let's plug that in. And now let's do a little magic. We're going to take our calculator and we're going to put 1/3 times 12 times 10. And when we do that, what do we get? 40. Don't forget your unit. This is in feet. And as we said before, to the 3rd power because it's 3-dimensional space. Let's move on to a cone. The volume of a cone is 1/3 the base times height. So what do I need to know? The base, area of the base, and multiply that by the height, and 1/3. So how is that done? I'll show you, because I like you. Check it out. Let's say we see our base. It's a circle. All right, so let's draw this out. We got our circle, and this has a radius of 7. Okay? That's our step 1. Step 2, let's find the area of it. So the area is equal to pi times r squared. That's how you find the area of a circle. So the area is equal to pi times 7 squared. So our area is, well, once again, I'm just going to tell you this. Let's just do our numbers. We're going to do it in terms of pi. Don't multiply by pi yet. That is just 49. And we're going to bring the pi down, pi. Let's transplant this and bring it in for our area of the base. All right, so it's 1/3 the area of the base, which is 49 pi, times the height, which is 13. We multiply this all together, okay? Except for the pi, let's multiply our numbers. So we're going to multiply 1/3, 49, and 13. Let's get out our trusty calculators. Let's put that in. 49. Oh, let's do 49 times 13 times 1/3. And we get, oh, we get a decimal. Cool. I'm excited. We get 212. Oh, sorry. Yeah, we get 212.333, and we bring down our pi. All right. Beautiful. So it's just a number, and we bring down the pi. Now, if we want to get the volume to now a decimal not in terms of pi, well, we're just going to multiply this by 3.14, right? Because pi is equal to 3.14, so we're going to multiply our answer times 3.14. And if you do that, you should get 666. Uh-oh, that's the devil's cone. 727. Now, since we are looking for this in the nearest hundredth, this is our hundredth place, the second one after the decimal. We're going to look at the number behind it. It's a 7, so we're going to have to round this up so that 2 becomes a what? That 2 becomes a 3, right? Because the 7 brings it up. So that is 7, 3. And that is our answer to the nearest hundredth. Utes. All right, we got one final question here, okay? It's another one of these back-solving things. A regular pyramid has a height of 8 centimeters. The volume of the pyramid is 240 cubic centimeters, and the width of the base is 10. What is the length of the base? Whoa, that's a complicated question. Not really. We learned how to do this. So the first thing we're going to do is write down the formula we need. Now, once again, this is all about looking at keywords. We know the volume, right, of a pyramid. So the formula we're going to write down is this guy. Volume equals 1/3 base times height. We have been given the volume, so we're going to plug in what we know for this problem, okay? So we know the volume is 240, all right? We know the height that was given to us, that is 8, but we do not know the base. But we can draw our base. So the base is a rectangle, okay? It's a regular pyramid, which means it has a rectangular or a square base, okay? We know the width is 10. Right? But we do not know the length. So if we don't know the length of our base, it's just an x. To find the area of the base, it's just length times width, right? Because this is a rectangle. So to find the area, it's just going to be 10 times x, which just gives us 10x, right? And x is our length. That's what we're looking for. So for the base, we're going to plug in 10x. Because that's the area of it so far. Now to solve, what do? Check it out. You just do 240 equals, and we multiply our numbers, right? So we're going to multiply 1/3, 10, and 8. All right, let's multiply those together. And you get 80. Oh, we get 80 over 3. All right, and that's fine. All right, when you multiply this together, you get 80 over 3, all right, x. Sorry, awkward cut there. I just wanted to write that a little nicer. So how do we solve this? I'm going to show you 2 ways, okay, because I like all of you. The first way to do that is we can get 80 over 3 as a decimal, okay? So 80 divided by 3 is just this. 240, and this is way 1 to solve it, equals 26.6667x. To solve, we're just going to divide both sides by 26.6667, right? Because we're just solving for x. And when we do that, 240 divided by 26.6667, you get 8.99999999999, which really, if you get all those 9s, is just 9, okay? So we get x equals 9. Now, I don't like that way to do it, but that's certainly a good way to estimate. Another way, which I kind of prefer for you guys to do, would be do it this way. All right, let's get rid of all this. So let's say you get 80 over 3, right? And you're like, what do I do now? If you have a fraction, the way you could always get rid of a fraction is just to multiply both sides by 3, right? You multiply by the denominator. When you do that, these 3's cancel on this side, and then you just have to multiply by 3 on this side. So 3 times 240 would be 720 equals 80x. That's a little prettier, right? No decimals. And we just divide both sides by 80, and we get x equals, well, 720 divided by 80 is 9. All right, so that means the length of this would be 9. Now, we could plug this in to see if we actually got that right, and I think that's actually a good idea. Let's see if this actually worked. You know, check your answers, see if you're making sense here. So is 240, which is the volume, all right, we're just going to plug everything in back to here, is equal to 1/3 times the base. Now, the base would just be 9 times 10, right, the length times the width. So 9 times 10 is 90 times the height, which is 8. All right, when I put that in the calculator, I get 240 equals 240, which is correct. All right, guys, that's it for this lesson. Stay true to your hearts and never ever look Mr. Elizondo in his eyes.
You'll die.
You'll die.